Okay. Next we are moving to the conventional problem for chapter 2, resistive elements. So here first problem, in the circuit shown in the figure, okay, this is a circuit, compute the circuit current and values of V1, all resistors are in kilo ohms. Keep it in mind, all resistors are in kilo ohm. So here the question, the first bit, current. So how to find out the current? According to Ohm's law, I is equal to V by R. So V is a 6 volt. What is R? R is equal to. So coming to here, this is the current direction from positive to negative. Same current is flowing 2 ohm, 2 kilo ohm, 1 kilo ohm, as well as same current is flowing 3 kilo ohm, same current is flowing 4 kilo ohm, same current is flowing for 2 kilo ohm. That means current is same. You can decide that the circuit is a series one, right? 2k plus 1k plus 3k plus 2k plus 4k. That may be equivalent to 3, 6, 8, 12, 12k. So that will be equivalent to V by R, V by 12k. So k is nothing but a 10 power 3. In the denominator it is a 10 power 3. In the numerator it is going to be 10 power minus 3 into 6 by 12, that is a 0.5. That means 0.5 milliamperes is answer. All of you got my point, right? Next, value of V1. So V1 is in between these two resistors, right? So the current, what is the current flowing through the series circuit is 0.5 milliamperes. That means what is the current flowing here? Here also it is a series circuit, 0.5 milliamperes. Once you know the current, in the second case, voltage V1 is equal to V is equal to IR, current into resistance. So but here not single resistor, two resistors in between. So two resistors are connected in series. So here R value is equal to 3k plus 4k, that is a 7k. Is it okay? That is a 7 kilo ohms. 7 kilo ohms. So I is equal to 0.5 milliamperes, 10 power minus 3 into R, 7 into 10 power 3 kilo, right? 10 power 3, 10 power minus 3 get cancelled. 7 5 is a 35, that is a 3.5 volt. What is the answer now? 3.5 volt. So this is about the first problem. Next, second problem. Calculate the voltage drops across the three series connected resistors. So all are in kilo ohms. So all resistors are in kilo ohms. You are find out in the voltage drop across each resistor. So it is easy, just look at here. So we have two ways to find out the voltage across V1, V2, V3. But you are attending the objective examination. One step only can find out the solution. That is required in the examination if you want to success. So that's why I will give directly voltage division rule formula. So what is the voltage division rule formula? You want to find out the V1 total voltage into if you want to find out the voltage drop across a V1, so let me take this the R1, R2 and R3. For your understanding purpose, I will write the formula here. So same resistance R1 divided by total resistance R1 plus R2 plus R3. Similarly, if you want to V2, so total voltage into same resistance R2 by R1 plus R2 plus R3. Everyone note down in your notebook, this is a voltage division. Don't apply this for current division. Maybe in the current division it is not similar, I into R1 divided by R1 plus R2. That is not similar in the current division rule. Already in the theory class I explained. Maybe in the coming problems, in the 8 problems are there is the conventional problems, there I will explain. So here V3 is equal to R3 divided by R1 plus R2 plus R3. So these three formulas whenever three resistors are connected in series, keep it in mind. So now we will find out the solution. Examination, you don't want to write all these formulas. For your understanding purpose, I will explain here. You should maintain running notebook. In that, you should note down these formulas. So total voltage is 12 volt. Same resistance 2k by total resistance 2k plus 3k, that is a 5k plus 1 6k. K get cancelled. Right, one time and 3 times, 1 time, 4 times. What is the voltage now? 4 volt is the answer. Got it? Right. Next, second case. Second case R2. What is the R2 value? That is a 3k, 12 into 3k by 6k total resistance. K get cancelled 2 times, 1 time, that is a 6 volt. Yes or no? We got 6 volt, right? Next, here 12 volt, 1k by 6k, k get cancelled 1 time, 2 times, it is a 2 volt. All together, we are combined together, we'll get the 12 volt. This is a way to find out the solutions, right? Okay. Next one, third problem. In the series network, this is a series network, compute the circuit current, power supplied by the battery. How will these changes if short is placed between the A and B terminals? A and B terminals, if you are short circuited, what will happen? All resistors are in kilo ohms. It is a 1k, it is a 1k, it is a 1k, it is sorry, this is a 5k, 3k, all this. First we are first point, circuit current I. In the normal condition, here two conditions are given. Short in between A and B, we will discuss after complete these normal conditions. So I is equal to V by R. What is the V? 30. R is equal to all R series, 1k plus 2k, 3k, 3k plus 3, 6k, 6k plus 4, 10k, 10k plus 5, 15k. That will be equivalent to 2 milliamperes. You got it or not? Yes. Next, second bit. What about the second bit? Power supplied by the battery. Power supplied, P is equal to V into I. What is the V? 30. What is the I? 2 milliamperes. That will be equivalent to 60 milliwatt. Yes or no? Yes. Next, second. First two steps are done. In case AB shorted. So let us whenever both are shorted, I will draw the diagram now. This 30 volt plus or minus, it is a 1k, it is a 2k, it is a 3k, as well as here 5k, here 4k, right? The A and B terminals here, A and B terminals. Now these two terminals are short circuited. So whenever short circuited these two terminals, current always flowing through the short circuit path. The current flowing this here is equal to 0. Whenever current is equal to 0 in this 2 ohm resistance, 2 kilo ohm resistance, 3 kilo ohm resistance, 4 kilo ohm resistance, that means total entire this particular portion is neglected, because there is no current flowing. Current total entire diverted into the A and B terminals. That means what is effective resistances? 1k and 2k. Now we are going to find current. I is equal to V by R. 30 divided by R is 1k plus 2k, that is a 6k, that is equal to 5 milliamperes. What will happen? Whenever short circuited, current will be increases in this case. So current is increases to 5 milliamperes. What about the power supplied by the battery? P is equal to VI. What is the voltage? 30. I is equal to 5 milliamperes. That is equal to 150 milliwatt. What is the power previously? So it is a 150 milliwatt. What is the power previously? 60 milliwatt. Now what is the power when after short circuited? 150 milliwatt. These are the changes in the circuit after short circuited. Okay. Next we are moving to the fifth problem. Very interesting one. In series voltage divider circuit. This is a series voltage divider circuit, right? Now the load current is 2 milliamperes. Yes, this is a 2 milliamperes. Maximum current from the battery supply is 10 milliamperes. Calculate the values of R1, R2 and their power ratings. Clear? It is a very simple. Just understand the circuit. So here you want to calculate the R2 and R1 resistances. So once you want to calculate this, this is a current, this is a resistance. We can find out the voltage, right? We can find out the voltage. That voltage is equal to I into R. I into R. For example, load voltage is equal to IL into RL. What is IL? 2 milliamperes. What is RL? 2K. That is equal to 4 volt. What is the voltage now? VL is equal to 4 volt. This is a parallelly connected, right? Whenever load is parallelly connected to R2, what about the polarity of voltage here? Plus and minus volt. Okay, now this is the 10 amperes, this is the 10 milliamperes, this is the 2 milliamperes. According to KCL, what is the current here? 8 milliamperes. You know the current, you know the voltage, you know the current, right? We can find out the R2. Yes, R2 is equal to R is equal to V by I. What is a V by I? That is a V is equal to 4, I is equal to 8 milliamperes. That means 0.2 kilo ohms. So answer is 0.2. I'm sorry, 1 by 4 is nothing but a 1 time 2 times 0.5 kilo ohms. Once we erase this, see here, 0.5 milli, 10 power minus 3 in the top, it is 10 power 3, that is a kilo, that will be equivalent to 500 ohms, right? So answer is 500 ohms. R1 is you got. What about R2? You can find out the R2 now. So next we are moving to the R1. R1, this is a 10 millivolt. This is a 4 volt, this is 10 milliamperes. This is a 4 volt, this is a 12 volt. What about remaining voltage drop across these terminals, right? 12 minus 4, that is equal to 12 minus 4, 8 volt, right? That is a 8 volt. You can find out R1 is equal to V by I. That is a V is equal to 8 by I is equal to 10 milli. That is equal to 0.8 kilo ohms. That will be equivalent to 800 ohms. That is R1 value. Yes, you got R1 value. So after that they are asking power rating of resistors, right? So the power rating of resistors here, P is equal to V into I. That is equal to P1 is equal to V into I. V is equal to in the first case 4 volt. Okay, V is equal to 4 volt into I. I is equal to what is the current I in the case of 8 milliamperes. In the case of first case, this is the P2, 8 milliamperes. That is equal to 32 milliwatt. What is the answer for P2? 32 milliwatt. It is 32, not 3 milliwatt, 32 milliwatt. Next, here P1. Again here P is equal to V into I. V is equal to 8 into I is equal to 10 milliamperes. That is equal to 80 milliwatt. Right. So answer is 80 milliwatt. All of you got idea? This is the way to find out the values of R1, R2 and power ratings. Okay. So next we are moving to the problem number 6. Here in the network shown in the figure, the equivalent resistance of a network. The first one, the equivalent resistance of a network. So what is the equivalent resistance of a network? How to find out? 6 ohm, 3 ohm and 2 ohm connected in parallel. So first find out, always you are find out in the resistance from opposite to the supply. So you should follow the resistance from this side. Don't consider these two parallel and parallel. If you are doing that, that is wrong. So everyone listen, this is a 6 volt, right? You should find out the solution from opposite to that, then only we'll get the correct answers. Then we are finding out these three are connected in parallel. 1 by R is equal to 1 by 2 plus 1 by 3 plus 1 by 6. Let me take LCM is 6, right? 3 plus 2 plus 1, that is equal to 6 by 6, that is equal to 1 ohm. 1 by R is equal to 1 ohm. R is also 1 ohm only. So you got R values of 1 ohm. That means 3 resistors are replaced by, I will draw the diagram here. 3 resistors are replaced by, here resistance replaced by 1 ohm resistance, equivalent resistance. What about here 0.2 and 6 volt? Here 0.2 volt and 6 ohms. Sorry, reverse it. 0.2 ohms as well as here 6 volt. Okay, You want total resistance. R equivalent total resistance is equal to 0.2 plus 1, that will be 1.2 ohms. Is it okay? So you got 1.2 ohms is the first bit. It is done. Next, values of branch currents. Before seeing the values of branch currents, I will tell you current and power supplied by the battery. Okay, so the current supplied by the battery, I is equal to, third bit I am doing, I is equal to current supplied by the battery, I is equal to V by R equivalent. What is a V? 6 volt. What is a R equivalent? 1.2. 6 divided by 1.2, that will be equivalent to 1 time 0.2 times. 1 by 0.2 is nothing but a 1 by 0.2 is nothing but a 5 amperes. What is the current now? Current supplied by the battery is a 5 amperes. Okay, next one, in the third bit itself, power supplied by the battery. So to calculate the power supplied by the battery, P is equal to V into I. What is a V? So V are 6 volt. I is equal to 5. That is equal to 30 watts is a power supplied. Just verify the answer in the third bit. 5 amperes, 30 watt. It is done. Coming to the values of branch currents. So second bit we are moving. So see here, second bit. Values of branch currents. So what are the branch currents? We have I1, I2 and I3. You know current division rule. So in the current, I will make you current division rule formula, then I will explain here. So everyone listen carefully. Current division rule I1. Total current, you know. What is the total current here? 5 amperes. Current supplied by the battery. So this 5 amperes is divided all 3 resistors. If 3 resistors are connected in parallel, this is the formula to find out the current directly. Total current into, okay. You want to find out the current flowing through the 2 ohm, right? What about the opposite resistances are 3 and 6. That means R2 and R3 by, this is the formula is applicable for 3 resistors are connected in parallel. Total resistance R1 R2 plus R2 R3 plus R3 R1. Very important. These are 5 amperes. R2 and R3, that is a 18 divided by R1 R2. R1 R2 is a 6 plus R2 R3, that is a 18 plus R3 R1, that is a 12. That will be equivalent to 5 into 18 by 36. 1 time, 2 time, it is a 2.5 amperes. What is the current now? Current will be equivalent to 2.5 amperes. Just verify here. Current is equal to 2.5 amperes. Got it. All of you clear about the current division rule formula? Everyone note down in your running notebook. Can these formulas, don't get confusion from 3 resistors are connected in series, 3 resistors are connected in parallel. Okay, maximum students are making the mistake of these 2 current division and voltage division rule formulas. Next, third, in the second branch current, I2 in the similar case, total current into, what is the total current? I will give the formula for this particular problem. While you find it in the I2, your I2 is nothing but opposite of these 2 resistors, R1 R3 by R1 R2 plus R2 R3 plus R3 R1. Total current is 5 amperes. So R1 R3, that is 2 into 6, that is equal to 12 divided by 36. This is a 1 time, this is a 3 times, that is equal to 5 by 3 amperes. So what is the current now? 5 by 3 amperes. Got it? Right. Next, I3. I3 can directly find out subtraction from 5 minus 2.5 minus 5 by 3 will get the I3. But we are applying the current division rule. For your understanding purpose, I am going to write once again formula for I3. So I3 is nothing but this particular resistance, opposite or 2. These two are multiplication, that is a R1 R2 by R1 R2 plus R2 R3 plus R3 R1. So 5 into here R1 R2 2 into 3 6. 6 divided by 36 one time 6, 5 by 6 amperes. You got current also 5 by 6 amperes. Just verify here, 5 by 6 amperes. All of you following? At the last step, last problem, last bit, current and power supplied by the battery is accidental short circuit occurs across A and B. Okay, so what is saying that this is also interesting one. See here, this is the fourth bit. Just look at the problem here. Current and power supplied by the battery accidental short circuited between A and B. So whenever A and B short circuited, you want to find out the current and power supply. That is the question, right? So see here, these two are short circuited. These two are short circuited. This is a short circuit current. Whenever these three are short circuited, what is a current, what is a power? Everyone carefully listen. Short circuited path is nothing but a resistance. Resistance is equal to 0. Short circuit path is nothing but a resistance is equal to 0. If 0 resistance connected in 3 ohm and 5 ohm, whatever it may be the resistances, all resistors are make it to the 0, negligible, because we are given the 5 amperes is current always flowing through the lowest resistance path. 2 ohm is there, 3 ohm is there, but 0 ohm resistance is there. Total entire 5 amperes is current flowing this particular direction. What about the I1 current is 0, I2 current is 0. Whenever current is 0, there is no question of these two resistors present in the circuit. Those are dummy resistors. We can neglect it whenever parallelly short circuited any resistance. So all parallel resistances are neglected. Finally, our resistance is only 0.2 only present. Now current I is equal to V by R, that is 6 by 0.2. So that will be equivalent to 30 amperes. Just verify the answer now. 30 amperes, right? Next, we are moving to the power supplied. Power supply P is equal to V into I. What is a V? 6. I is equal to 30. 180 watts. But one thing you need to remember. What about the actual current? Normal case current is 5 amperes. But whenever that is a short circuited, what about the current? Very high. Right? What about the power dissipated? Power dissipated in the previous case, in the second case, 30 watts. Here, 30 watts. Right? What about the power dissipated now? 180 watts. That means whenever short circuit occurs, the parameters of current increases, power also increases. That is one of the objective question in the previous paper, right? So this is about the explanation. Next, problem number 8. So here problem number 8, 7th problem is similar to the problem number 6. That's why I skipped that problem. So 8th problem we are going to do. Calculate the various branch currents in the circuit. All resistor values are in ohms. In ohms only, not kilo ohms, right? So this is a branch. This is a current I1 branch current, I2, I3, and I4. So how to find out the values of all these currents? Look at here. If you understand this problem, we can do any problem in the current division rule, right? So this is a 10 amperes. That is the total current. Right, this total current is divided I1 and I2 here. I2 here 1 ohm, right? I1 and I2. So to find out these currents, so in this particular circuit, I want to find out the two currents first, I1 and I2. These two currents. So look at here. This is a 6 ohm. This is a 3 ohm connected in parallel. So 6 into 3 by 6 plus 3, that is equal to 18 by 9, that is equal to 2 ohms. All of it clear? So I can replace this 6 and 3 by 2 ohms, right? So I will make the 10 amperes, the current here I, this is a I1, that is a 6 ohm, this is a 1 ohm, and this 2 replaced by 2 ohm, right? Still now it is okay, right? So this current is I2. Now 2 and 1 connected in series, right? That means what is the resultant resistance? 3 ohms. Still now it is okay. Now I am applying the current division rule for this particular circuit. So what is the total current here? 10 amperes. Once again, the students doing a mistake here. If it is current source is given, then only can take directly 10 amperes. If voltage source is given, your voltage is a V is equal to 10 volt for example. Don't take here 10 amperes directly. In the examination, your mindset will be hurry up, 1 minute time is there. That's why it can properly visualize the circuit. Concept of current division rule, and then whether it is a current or voltage source decided, then only apply. Okay, don't hurry up in the examination. So it is a 10 amperes, that's why current is equal to 10 amperes applied to the both the resistors. Now I1 is equal to current division rule, total current into, what is the total current? 10 into opposite, this is a total current I1, opposite resistance is not 1 ohm, together you should consider, because total current is supplied, I2 is supplied to both the resistors, series connection only. That's why 3 divided by total resistance, 6 plus 3, 9. So 1 time, 3 times, 10 by 3 is equal to 3.33 amperes. What is the current now? 3.33 amperes or 10 by 3. It is given 10 by 3, no issue. So all of you got the idea about I1, right? What about I2? I2 is equal to, again, total current into, you want I2. So opposite resistance is 6 by total resistance, it is a 9. So one more thing I need to repeat. For example, here resistance is there. Let me take the example. This resistance is there for 10 ohms. One of the students, they asked the particular doubt. This 10 ohms considered in the current division rule? No, because total current is flowing through this 10 ohm resistance. It is 10 ohm resistance current is not responsible to division of current in the 10 ohm resistance. That means the 10 ohm resistance should not consider in these calculations. Only consider where current is divided, right? So 2 times here, 3 times, 2 by 3, that is equal to 20 by 3 amperes is the current. So here in the problem, here 10 by 3 amperes is the current, here 20 by 3 amperes is the current. Look at here, 20 by 3 amperes. Done. What about remaining 2 currents you need to find out? Carefully listen. Here I am going to explain. Remaining 2 currents. What is the I2 current now? 20 by 3 amperes. Once you know this 20 by 3 amperes current, now here apply current division rule for these 2 resistors only, because this is the total current now here in this particular loop. So I3 is equal to, now what is the total current? 20 by 3 total current into, you want to find out the current I3, right? Opposite is 3 by total 6 plus 3, 9. Clear? Don't consider again here 1 ohm, because 1 ohm is responsible for I2 only. I2 total current, you know, that is divided into I3 and I4. So 1 time here 3 times, that is equal to 20 by 9 amperes is the current. What is the current now? 20 by 9 amperes. See here, 20 by 9 amperes. Next I4. I4 is equal to, again, total current 20 by 3 into opposite I4, right? Opposite is 6 divided by total 9. 2 times, 3 times. That will be equivalent to 40 by 9 amperes. Just verify the answer here. 40 by 9 amperes. I hope that it is a conventional problems practice section for the chapter 2 resistive elements. I hope that you are enjoy the classes.